Have you ever looked up at the night sky and wondered about the vastness of the universe? It's a question that has captivated us since the dawn of civilization. We gaze at the stars and marvel at the infinite expanse of space, pondering our place within it. The universe, in its grandeur and mystery, is a concept that is both awe-inspiring and at times overwhelming. The universe, as we understand it, is a vast, seemingly endless expanse of space that began around 13.8 billion years ago. It's a space that holds everything we know and don't know. From the tiniest particles to the largest galaxies, everything exists within this cosmic arena. Speaking of galaxies, did you know there are estimated to be around 2 trillion galaxies in the observable universe? That's right, 2 trillion. Each one is a grand cosmic city, home to billions, even trillions of stars, along with a myriad of planets, asteroids, comets, and more. Now you might be wondering, how do we measure such immense distances in space? Enter the light year. A light year is not a measure of time, but a measure of distance. It represents the distance that light, which moves at a speed of around 300,000 kilometers per second, can travel in 1 year. In terms of miles, that's nearly 6 trillion miles. So, when we say a galaxy is a billion light years away, we're saying that the light we're seeing from that galaxy today actually started its journey towards us a billion years ago. It's like looking back in time, a cosmic time machine, if you will. As we delve deeper into the mysteries of the universe, we realize how tiny we are in the grand scheme of things. But isn't it incredible that we, tiny specks on a tiny planet, can look up at the night sky and begin to comprehend the vastness of it all? Did you know that our home, the Earth, is part of a much larger cosmic family called the Milky Way? That's right, we reside in a galaxy known as the Milky Way, a place that's as mysterious as it is magnificent. The Milky Way is a barred spiral galaxy. Imagine a whirlpool spiraling out from a central point. That's what our galaxy looks like from a distance. Picture a flat disk with arms spiraling outwards, all swirling around a central bulge. We Earthlings, along with our solar system, are located in one of these spiral arms, specifically in a place known as the Orion Arm. Now let's talk about the scale of the Milky Way. It's hard to comprehend just how vast it is. Our galaxy is estimated to be about 100,000 light-years in diameter. That means if you were traveling at the speed of light, it would take you 100,000 years to go from one end of the galaxy to the other. And that's just one galaxy. But what's inside this vast expanse? Well, the Milky Way is teeming with stars. Scientists estimate that there are about 200 billion to 400 billion stars within our galaxy. Each of these stars could potentially host its own solar system, with planets, moons, and asteroids. Our solar system, with the Sun at the center, and the Earth and other planets orbiting it, is just one of these many systems. The Milky Way is also home to countless interstellar clouds of dust and gas known as nebulae. These nebulae are the birthplaces of stars, where new stars are constantly being formed. As we journey through the cosmos, remember this: the Milky Way is our cosmic address. It's our home in the universe, a tiny speck in the grand scheme of things, but a crucial part of the cosmic story. Our Milky Way galaxy is just one among billions, each with its own unique shape and size. So, as we gaze up at the night sky, let's remember the vastness of our galaxy and the countless mysteries it holds. Imagine a city filled with billions of citizens. Now imagine these citizens are stars. Welcome to the world of galaxies. Galaxies, these cosmic cities, come in a variety of shapes and sizes, each with its own unique charm. At the heart of these celestial metropolises, you'll find billions, even trillions of stars, each playing a vital role in the galaxy's existence. First, let's take a stroll through our own neighborhood, the spiral galaxies. These galaxies get their name from their shape. A flat, rotating disk with a bulge in the middle, all wrapped in a halo of stars and dust. Picture a cosmic pinwheel, spinning through the vastness of space. Our very own Milky Way is a prime example of a spiral galaxy, with an estimated 200 billion stars calling it home. Next on our cosmic city tour are the elliptical galaxies. These galaxies are the giants of the universe, often containing up to 10 times more stars than spiral galaxies. Unlike their spiral siblings, elliptical galaxies lack the pinwheel shape and instead appear as round or elongated spheres. They're like the bustling megacities of the cosmos, crowded with stars but lacking in gas and dust needed for new star formation. Finally, we arrive at the irregular galaxies. As the name suggests, these galaxies don't fit into the spiral or elliptical categories. They're the cosmic equivalent of a small town, often smaller in size and with fewer stars. However, their charm lies in their unpredictability. With no defined shape, they're like abstract art pieces floating in the universe, each with its own unique story to tell. So there you have it. From the spiraling suburbs of spiral galaxies to the bustling metropolises of elliptical galaxies, and the charming unpredictability of irregular galaxies, the universe is teeming with these cosmic cities. Each galaxy, each star within it contributes to the grand cosmic ballet that is our universe. They're more than just clusters of stars, they're communities, each with its own set of rules, its own residents, and its own unique story to tell. Each galaxy is a unique cosmic city with its own set of rules and residents. What if someone told you that the universe, with all its galaxies, is expanding every second? It may sound like a science fiction plot, but this is a reality we're living in. The concept of an expanding universe isn't new, it has been a cornerstone of cosmological theories for decades. This revelation first came to light in the early 20th century, when an American astronomer named Edwin Hubble made a startling discovery. Observing distant galaxies, Hubble noticed something peculiar. The galaxies appeared to be moving away from us, and the further away they were, the faster they seemed to be retreating. This led to the groundbreaking conclusion that the universe was not static, but expanding. But what does this really mean? Imagine if you were standing on a balloon as it was being inflated. As the balloon expands, you would see all points around you moving away. That's pretty much how the universe is expanding. But it's not just the galaxies moving away from each other. The very fabric of space itself is expanding. Now you might wonder what's causing this cosmic expansion. The answer lies in a mysterious force known as dark energy. Though we can't see or directly measure dark energy, we know it's there because of its gravitational effects on galaxies and galaxy clusters. This elusive energy is thought to make up about 70% of the universe, and it's this force that's driving the universe's relentless expansion. So what does this mean for the future of the universe? Well, if this expansion continues unabated, distant galaxies will eventually move so far away they'll become unreachable and invisible to us. The night sky as we know it will change dramatically, with fewer stars and galaxies visible to the naked eye. However, it's not all doom and gloom. This expansion is also a testament to the dynamic, ever-evolving nature of the universe. It's a reminder that the cosmos is a place of constant change and infinite possibilities. So the next time you gaze up at the night sky, remember this. As the universe expands, so does our understanding of our place in it. Where is the universe heading? What does the future hold for our cosmic home? These are questions that have intrigued humans for centuries. As we look up at the night sky, we can't help but wonder about the destiny of the cosmos. Let's delve into some of the most popular theories that scientists have proposed. First up is the Big Freeze, also known as heat death. According to this theory, as the universe continues to expand, it will eventually reach a state where all the stars have burned out, leaving behind only black holes. Over unimaginable spans of time, even these black holes will disappear, evaporating into a faint mist of particles. The universe will become a cold, dark, and incredibly vast expanse with temperatures approaching absolute zero. It's a chilling thought, isn't it? On the other hand, we have the Big Crunch theory. This is almost the reverse of the Big Freeze. In this scenario, the expansion of the universe doesn't go on forever. Instead, at some point, gravity gets the upper hand and the universe starts to contract. This leads to a reversal of the Big Bang, where everything in the universe collapses back into a singular point, a fiery, dense end to the cosmos as we know it. But as you can guess, these are just theories. The future of the universe is still largely unknown. We don't know whether the universe will continue expanding indefinitely, or if it will one day start to contract. We don't know if the universe will end in fire or ice, but that's what makes cosmology so exciting. It's a field of study that is always evolving, always pushing the boundaries of our understanding. No matter what the future holds, the study of the universe will always fascinate us, pushing the boundaries of our knowledge and imagination. So, let's keep looking up, keep wondering, and keep exploring the infinite wonders of our cosmic home.